Hello friends, myself Borhade Ganesh. Today learn about ideal and practical transfer characteristic of the op-amp. Op-amp means the IC741 operational amplifier. What is the meaning of transfer characteristic? Transfer characteristic are the characteristic which transfer the input signal to the output. Okay, therefore, this characteristic is known as the transfer characteristic. And in operational amplifier, transfer characteristic plotted Vd versus V0. Vd means the input voltage, that is the differential input voltage, versus V0 means the it is the graphical representation of the input voltage versus output voltage. These are the ideal and the practical transfer characteristic of the op-amp. It is the graph of input voltage Vd versus output voltage V0. Okay. In op-amp, how to calculate the output voltage? The output voltage V0 is equal to AOL, means the open loop gain, into V2 minus V1. V2 minus V1 means the Vd. Vd means the differential input voltage. If V2 is less than V1, V2 means the non-inverting voltage is less than the V1, means the inverting quantity is more. That time, what is the output voltage? V0 is equal to minus AOL into Vd, means the output voltage is the negative. And if the non-inverting voltage V2 is greater than V1, that time what is the output voltage? V0 is equal to plus AOL into Vd. AOL means open loop gain into Vd. Put the value of in this equation, then get the output voltage is the positive. Okay. From this formula, we can calculate the output voltage. For op-amp, V0 is equal to AOL, means the open loop gain, into differential input voltage. By this formula, we can calculate the output voltage. The next condition, if the V2 is equal to V1, means the both the non-inverting voltage and the inverting voltage are equal, then what is the differential input voltage? Is the 0. Then put the value of 0 in this equation, then what is the output voltage? V0 is equal to 0. Okay. Then this is the ideal transfer characteristic of the op-amp. These are the three conditions. For op-amp, the output voltage is equal to gain into the differential input voltage. Consider the open loop gain of the op-amp is infinite, means it is very high. Then first condition, if V2 is greater than V1, then find out the output voltage V0. Then the output voltage is the infinite or equal to plus VCC or is equal to plus V saturation. In op-amp, always remember the output voltage, maximum output voltage, is equal to the plus VCC and the minus VCC. Means whatever the energy source apply to the op-amp, that is your maximum output voltage. It is known as the saturation voltage. Means V2 is greater than V1. V2 means the non-inverting voltage. Means the non-inverting quantity if greater than V1 inverting quantity, then the output voltage is the plus V saturation. Second condition, if V2 is less than V1, means the inverting quantity is more than the non-inverting quantity. Then AOL means the open loop gain is the infinite. Then calculate the output voltage. The output voltage is equal to the minus infinity, means equal to the minus VCC is equal to minus V saturation, right? And if V2 is equal to V1, means the non-inverting voltage is equal to the inverting voltage, and the VD is equal to then 0, then what is the output voltage? 0. Means if from this characteristic we can understand, if the VD is equal to 0, then the output voltage also 0. If the V2 is greater than V1, then the output voltage is the plus V saturation. And if V1 is greater than V2, then output voltage is the minus V saturation. This is the ideal transfer characteristic of the op-amp. Then practical op-amp transfer characteristic. In this case, consider the AOL is finite, means it having some value. Then if first condition, if V2 is greater than V1, means the non-inverting quantity is greater than inverting quantity, then what is the output voltage? That is the V0 is equal to plus gain into differential input voltage, means the output voltage is the plus V saturation. Means as we increase the input voltage, that is the differential input voltage, the output voltage increases, and at the maximum value it become constant, right? That is the plus V saturation. Remember, in op-amp the maximum output voltage is the plus V saturation. Second condition, if V2 is less than V1, means the inverting quantity is more, that time what is the output voltage is the minus V saturation. And if both the quantity, inverting and non-inverting quantity, are equal, then what is the differential input voltage? That is the 0. Therefore output voltage is also 0. Okay, this characteristic is known as the practical transfer characteristic of the op-amp. Then this region is known as the linear region of the op-amp. From the practical characteristic, we can say this region is known as the linear region, right? Linear region. In this region only the op-amp is act as an amplifier, and this is the non-linear region. Okay, in this region output get distorted, means in this region op-amp cannot be act as an amplifier. Then these are the application of the operational amplifier in linear and the non-linear region. Linear means the in the linear region, in this region the amplifier means the op-amp act as an amplifier. The application, inverting amplifier, non-inverting amplifier, unity gain buffer, V2I converter, I2V converter, instrumentation amplifier, integrator and differentiator, summer, or the it is known as the adder. And non-linear region means in this region the application are comparator, Smith trigger, precision rectifier, log amplifier, anti-log amplifier, clipper, clamper, peak detector. These are the application of the operational amplifier in linear and the non-linear region. Okay friends, thank you.